In episode 74, titled Validation Hygiene, Data Splits, Leakage Prevention, and Reproducibility, the goal is to validate correctly so performance numbers mean something real, because a perfect metric on a flawed evaluation is worse than a mediocre metric on an honest one.
The exam cares because many scenario questions are really about evaluation integrity, and the correct answer is the one that protects against leakage, respects time and grouping structure, and produces results you can reproduce and defend.
In real systems, validation hygiene is how you keep teams from shipping models that look great in development and then fail immediately in production. It also protects stakeholder trust, because once performance claims are questioned, rebuilding confidence is harder than doing validation right the first time.
Good validation is not a single step. It is a discipline that starts before modeling and continues through documentation and communication. If you build this discipline, your models become credible because your numbers mean what you think they mean. Before we continue, a quick note. This audio course is a companion to the DataX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. The first decision is how to split data, and the right split depends on the problem structure, not on convenience.
Random splits can be appropriate when observations are independent and the data-generating process is stable, because they produce training and evaluation sets drawn from the same distribution.
Stratified splits are appropriate when classes are imbalanced, because they preserve class proportions across splits and reduce the chance that one split contains too few positive cases to evaluate reliably.
Time-based splits are appropriate when time ordering matters, because the real task is to generalize from past to future, and mixing time periods can leak future patterns into training.
The exam expects you to choose splits based on the scenario, such as time-aware validation for forecasting and churn when behavior changes over time.
Split choice is the foundation of validity, because a model can look good simply because the split was easy, not because it will generalize.
When you narrate split strategy, you should describe what dependency or drift risk you are addressing with that choice.
Keeping test sets untouched until final evaluation is needed is one of the most important hygiene rules, because the test set is only meaningful if it stays independent of your decisions. If you look at test performance and use it to choose features, models, or thresholds, you are optimizing to the test set, and it stops being a fair estimate of future performance.
The exam often includes this as a trap by suggesting repeated evaluation on the test set, and the correct response is to treat the test set as a final check after the model design is locked. This discipline preserves trust because you can claim that the final test score represents out-of-sample performance rather than a tuned result. It also protects you from subtle confirmation bias because humans naturally prefer changes that improve the most visible number. When you keep the test set untouched, you preserve the integrity of the final performance claim. Pre-processing must be fit only on training data to prevent leakage, because pre-processing often computes statistics that can inadvertently incorporate information from evaluation data. Scaling parameters, imputation values, encoders, bin boundaries, and transformation parameters should be estimated from training data only, then applied to validation and test sets using the same fitted rules. If you fit pre-processing on the full dataset, you allow evaluation period information to influence the representation the model learns from, inflating performance and producing overly optimistic metrics. The exam expects you to treat pre-processing as part of the model pipeline, subject to the same training evaluation boundary as the model itself. This also matters for reproducibility, because the pipeline must be consistent between training and inference, and training-only fitting mirrors how the system must behave in production.
When you narrate pre-processing hygiene, you are demonstrating that leakage is not only about obvious future fields, it can occur through any fitted transformation.
Leakage features are another common threat, and detecting them is a key exam skill because leakage can produce dramatic, misleading performance improvements. Identifiers like user IDs, device IDs, or transaction IDs can leak because they allow memorization of historical outcomes rather than learning generalizable patterns. Future fields can leak because they are only known after the decision point, such as investigation outcomes, remediation actions, or post-event statuses.
Target proxies can leak because they encode the target indirectly, such as fields generated by workflows triggered by the target, or fields that are near-duplicate representations of the outcome. The exam often describes features that sound highly predictive and asks whether they should be used, and the correct answer is to reject them if they are not available at inference time or if they are downstream of the outcome. Leakage detection is easiest when you ask how and when a feature is generated relative to the target, because time and process are the true tests. When you treat suspiciously powerful features as possible leakage, you protect both validity and governance.
Cross-validation is useful when data are limited and variance is high, because it provides multiple train validation splits and produces a distribution of performance rather than a single noisy estimate. When sample size is small, or when the positive class is rare, a single split can be misleading, and cross-validation helps you see whether performance is stable or fragile. Cross-validation also helps in model comparison because it reduces sensitivity to one lucky split that favors one model. The exam expects you to recognize cross-validation as a tool for stability, not as a replacement for time-aware validation when time ordering is essential. In time-dependent settings, you may use time-aware cross-validation variants conceptually, but the key point remains: you should not mix future into past. When you use cross-validation appropriately, you are measuring not only average performance, but also variability, which is crucial for honest communication.
Reproducibility requires tracking seeds and versions, because if you cannot reproduce splits and outcomes reliably, your performance claims become fragile, and your iteration history becomes untrustworthy. Random seeds control split randomness, sampling, and certain model behaviors, so tracking them ensures you can rerun an experiment and obtain the same results. Version tracking includes data snapshots, code versions, feature definitions, and pre-processing configurations, because changes in any of these can change outcomes. The exam expects you to treat reproducibility as part of validation hygiene, because without it, you cannot distinguish genuine improvements from accidental differences in data or pipeline. Reproducibility also supports auditing, because stakeholders may ask how a model was evaluated and what changed between versions. When you track seeds and versions, you make your evaluation chain defensible rather than anecdotal.
Scenario-specific validation plans are where these principles become practical, and churn, forecasting, and anomaly detection illustrate distinct needs the exam often tests. For churn, time-aware splits are usually appropriate because churn behavior evolves and because you want to evaluate on future customers or future periods, not on shuffled snapshots that leak future patterns.
For forecasting, time-based validation is essential because the whole point is predicting future values, and random mixing defeats the problem definition. For anomaly scenarios, group-aware splits may be needed because many events are correlated within an entity, and near-duplicate patterns can leak across random splits if the same entity appears in both sets. The exam expects you to justify the split strategy based on these structural differences, rather than treating all problems as IID. When you narrate a plan for each scenario type, you demonstrate that you can adapt validation hygiene to real-world structure.
Repeated tuning on the test set is a trust killer because it transforms the test set from an impartial judge into a collaborator that has influenced your choices. Even if you do not intend to overfit, Each time you observe test performance and decide what to change, you bias your design toward that particular sample. The exam often frames this as a warning, and the correct reasoning is to use validation for tuning and reserve test for a single final evaluation, possibly followed by a locked report. If you truly need a new estimate after changes, you should create a new holdout or use additional data, but you should not reuse the same test set as a tuning guide. This discipline supports stakeholder trust because it allows you to claim that final performance was not cherry-picked. When you avoid test tuning, you keep evaluation honest and you keep your reputation intact.
Recording a full picture of results means capturing metrics, confusion matrices, and calibration, because a single number rarely explains whether the model will behave well in deployment. Confusion matrices show the types of errors being made, which connects directly to operational cost and capacity planning. Calibration shows whether predicted probabilities correspond to real outcomes, which matters when downstream policies depend on risk thresholds. Segment-level metrics reveal whether performance varies across groups, which matters for fairness, risk concentration, and operational planning. The exam expects you to include this broader view because it demonstrates that you understand metrics as tools for decision quality, not as scores for competition.
A full picture also prevents unpleasant surprises, such as a model that improves overall accuracy while dramatically increasing false positives in a critical segment.
When you record these artifacts, you create an evidence package that supports both technical decisions and stakeholder communication. Documentation of pipeline steps, transformations, and feature selection decisions is part of validation hygiene, because without it, no one can reproduce the evaluation or trust that it was done consistently. Documentation should include how data was filtered, how missingness was handled, what encodings were used, what transformations were applied, and what features were excluded and why. It should also include the split logic and any time cutoffs, so the evaluation can be audited for leakage. The exam expects this because a model's performance is a property of the entire pipeline, not just of the algorithm. Documentation also supports iteration, because when performance changes, you can identify whether the change was due to features, pre-processing, or evaluation design rather than guessing. When you document thoroughly, you make your validation results durable and defensible. Uncertainty should be communicated because even with good hygiene, performance varies across folds, time periods, and segments, and pretending otherwise leads to overconfident decisions. Variability across folds can indicate sensitivity to sampling, and variability across time periods can indicate drift or seasonality effects that may continue after deployment. Communicating uncertainty means reporting ranges, describing stability, and explaining what conditions the model was evaluated under, so stakeholders understand what performance actually represents.
The exam often tests whether you will overclaim from a single metric, and the correct response is to acknowledge variability and conditions.
This also supports responsible deployment because decision thresholds and monitoring plans should consider the possibility of performance degradation under different conditions. When you communicate uncertainty honestly, you strengthen trust because you align expectations with reality. A helpful anchor memory is split first, fit second, evaluate last, then lock. Split first means you define the evaluation boundary before you build models, so you do not accidentally tailor decisions to the evaluation set. Fit second means you fit pre-processing and models using training data only, preserving the integrity of validation and test.
Evaluate last means you use validation for iteration and reserve test for a final estimate. Then lock the model design and report the result without further tuning. This anchor captures the core hygiene workflow the exam expects you to follow, especially in scenario questions where leakage and reproducibility are the real challenges.
It also reinforces that evaluation is a process, not a single calculation. When you follow the anchor, your numbers become credible because they were generated under a disciplined, repeatable protocol. To conclude episode 74,
State a validation plan for one scenario aloud, because this is how you demonstrate that you can apply hygiene under realistic constraints.
Suppose the scenario is churn prediction, where customer behavior evolves over time, and the model will be used to prioritize outreach for the next month.
A defensible validation plan is a time-based split where you train on earlier months, validate on a subsequent period to tune features and thresholds, and hold out the most recent period as an untouched test set for final evaluation. You would fit all pre-processing, including encoders, scalers, and imputers, on the training data only, then apply them unchanged to validation and test to prevent leakage. You would evaluate using ranking metrics for prioritization, calibration checks if probabilities drive outreach intensity, and confusion matrix-derived metrics at the expected outreach capacity to reflect operational constraints.
You would track seeds, data versions, and pipeline configurations so the split and results can be reproduced, and you would report variability across time windows to communicate uncertainty.
This plan keeps the evaluation honest, aligns with how the model will be used, and produces results stakeholders can trust.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.